Bismillahirrahmanirrahim. Assalamu alaikum. Today I am going to solve Cambridge O-level exam of Physics Paper 2 Theory for the subject code 5054 and the variant is 22 for the session of June 2023, and we have 1 hour 45 minutes. The total mark for this paper is 80. This is a P2. We're gonna start from the question number 1. The question number 1 is figure 1.1 showed the speed time graph for a car traveling on a straight horizontal line. This is the question from the kinematics. For the first part A, we need to describe the motion of the car as shown in the figure 1.1. We can see that for the first 10 seconds the object is clearly moving with the constant speed, and for the rest of 40 seconds up till 10 till 50 the object gradient the graph gradient is decreasing, so it means that speed is decreasing and the object is decelerating. So we're gonna write that the object is moving with constant speed for the first 10 seconds. So for the first 10 seconds the object is moving with constant speed, and for the rest of journey we can see that as the slope is decreasing the car is decelerating. For next 10 till 40 seconds the slope is decreasing the car is decelerating. Okay, for the next part at time t is equal to 10 seconds the car is switched off, the brakes are not applied. Name two forces that act on the car that causes the change of the motion after 10 seconds. So we know that when the brakes are not applied but the speed is decreasing, it means due to the friction and due to the air resistance. So we're gonna write over here friction and air resistance. So that was a simple part. Suggest why figure 1.1 is curved after t is equal to 10 seconds. Because it is curved because the resistive force are acting on it and the speed is changing, and we can say that the speed is constantly decreasing, that's why it is curved, but it is not decreasing uniformly, so that's why it is decelerating. So we're gonna write over here the speed is decreasing or a non-uniform decrease in the speed. So this was an easy part, or you can also say that resistance forces helping it to decrease, but you need to write only one point: resistive forces change So we're gonna move to the next part of question 1, that is part C. Between t is equal to 0, between t is equal to 10 second and t is equal to 20 second, the speed of the car changes from 18 meter per second to 11. The mass of the car is 1200 kg. Calculate the change in momentum of the car in this time. Give your unit. Okay. So this is an easy question. The question is about the change in momentum. What is momentum? Momentum is actually the product of mass into velocity. We need to calculate the change in momentum. Change in momentum means delta p. We have a formula for delta p is mass constant equal to change in velocity. We're gonna note that what is the mass is 1200 kg, and the velocity is changing from 18 meter per second to 11 meter per second. So we're gonna write its change in velocity 18 minus 11, 1200 into 7, the answer would be 8400. And we need to write the unit as well. The unit for the momentum is kg meter per second, kgms minus, or you can write other unit as well, that is Newton second. It's your choice, whatever unit you want to use. Calculate the average resultant force exerted on the car during this time. So what is actually the formula for the force relating to the momentum? The formula relating to the momentum for the force is the change in momentum is equal to over, rate of change of momentum is called force. So what is the change in momentum? We calculated in the previous part, that is 8400. What is the time? The change in time from t is equal to 10 second to t is equal to 20 second, that is 10. The answer is 840 Newton. So the change in the resultant force is equal to the change rate of change of momentum, that is 840 Newton. That was an easy part. Now we move to the question number 2. Question number 2 is figures 2.2 shows a rider on electric scooter. The scooter contains a battery and a motor to drive the back wheel. State the name of energy that's stored in the battery. So examiner tend to ask such type of question, in which examiner asks what kind of energy it is possessed. Whenever the battery is written, you need to answer it. It's a chemical energy stored. Describe in terms of work done the stages of energy transfer from the energy stored in the battery to the kinetic energy of the scooter. So the energy stored in electric energy and electrical energy is by moving of electron, that is due to the current. Then it has converts into kinetic energy, due to it mechanical energy produces. So we're gonna write electrical work or energy, which is movement of electrons, it is actually current, produces mechanical energy, or you can write kinetic energy. So answer is completed. Next part is the total mass of the scooter is 70 kg. Calculate the total kinetic energy of the rider and scooter when the scooter has a speed of 4 meter per second. So what is the formula for the kinetic energy? Kinetic energy has a formula of 1 over 2 mv square. So we have been given the mass of the scooter is 70, and velocity square is 4. I'm gonna calculate, answer would be 560 joules. So we're gonna write over here 560 joule. So this is the answer. Let's see, 560 joule. Now we move to the next part of question number 2. The battery is marked energy capacity 0.35 kilowatt per hour. Describe what is meant by kilowatt per hour. Kilowatt is the energy used to power 1 kilowatt for an hour. So it is a unit of electric power. The smaller unit of power is watt, but kilowatt hour is a bigger unit. So we're gonna write over here, it is the energy needed to power 1 kilowatt for an hour. The next part is the scooter stops working because the battery is totally discharged. It means flat. This means that there is no energy stored in the battery. The battery is then recharged using a 70 watt power supply. Calculate the time taken to fully recharge the battery. So we have the formula for the power, which is equal to power is equal to energy over time, or W by time. The energy is given, that is 0.35. This is energy. We need to divide 70 watt into kilowatt. The 70 divided by 1000, the answer would be 0.07. So we're gonna write over here 0.07. The answer would be 5 hours. So time taken to full charge the battery is 5 hours. This was an easy question. All we do need to is to memorize this formula. P is equal to E by T, or W by T. The power is actually rate of change of work done. Now we move to the question number 3. Question number 3 is related to pressure and atmospheric pressure. A fixed mass of gases in a glass tube is tapped by a steel at one end of the tube and by a column of mercury. We can see the level of mercury and end of the tube, and the mercury is free to move within the tube. This is allowed to free to move. The tube is rotated slowly like that from the vertical to horizontal figure as shown. The volume of the gas increases and the temperature remains constant. Describe why rotating the tube changes the pressure of the gas in the sealed end. So we're gonna write here, mercury stops entering a pressure on the sealed end and when it is in the horizontal position. It means that when it is changing into the horizontal position, the mercury, and it doesn't allow the pressure to change. So we're gonna write over here, mercury stops exerting a pressure when it is in horizontal position. The formula for the pressure is rho g h, density, gravity, and the height. Okay, explain using the idea about particles why the pressure of the gas decreases when its volume increases. Pressure exerted due to the particles hitting the wall or colliding with the wall. So we're gonna write over here pressure is exerted due to particles hitting the wall. So when the volume increases, increases, there is a fewer hit per second. There is a fewer hit per second. So pressure and force decreases. In figure 3.1, next part is in figure 3.1, the mercury column is in figure 3.1 the mercury column is 0.3 meter. The density of the mercury is 14,000 kilogram per meter cube. Atmospheric pressure is 1 into 10 is to power 5 pascal. Calculate the pressure of the gas in the tube. So formula we are already provided, P is equal to rho g h. What is density? Rho g h. The density of the mercury is 14,000 and G we're gonna use 9.8 because it is written on the instruction of the paper, and height for the column is 0.3. So the answer would be 41,000. We're gonna write only two significant figure up to. Okay, the total pressure of the gas would be by adding the atmospheric pressure of the gas. So 41,000 plus atmospheric pressure, that is equal to 1 into 10 is to power 5. The answer would be 1410. So we need to write only two significant figure for the answer. We need to adjust the paper. 14 pascal. Okay, good significant figure. So question number 3 part B is completed. Now moving to the part C. The pressure of a different sample of gas changes at constant temperature. Okay, figure 3.3 shows one point marked at X on the graph of the pressure, speed, volume for the gas. At X, pressure of the gas and its volume is V0. On figure 3.3, sketch the graph of the pressure of the gas decreases from 2P0 to half P naught. Oh, so first we need to know the Boyle's law, that is pressure is inversely proportional to volume. When applying constant K by V, then pressure and volume is equal to K. We know that P naught, V naught are given, that is the point X is showing over here. When the pressure is double, the volume is half, so 2B. And when the volume is double, the pressure is half. So we're gonna plot this line by smoothly. So this is how we're gonna show. By plotting it, the pressure is inversely proportional to the volume. We have completed the question number 3. Now the question number 4 belongs to the heat and temperature. Figure 4.1 show the particles atom at one instant in a sample of iron at temperature below its melting point. State the lowest possible temperature on Celsius scale and on the Kelvin scale. The lowest possible temperature for the Celsius scale is minus 273 degrees Celsius, and for the Kelvin scale it is 0 Kelvin. The temperature of the second part is the temperature of the solid increases, the sample remains a solid. Describe how the motion of particle changes. When the temperature increases, particles will vibrate faster or rapidly. Particles will vibrate rapidly with higher energy and amplitude. So the solid mass state, what happens to the internal energy and temperature of the solid as it melts. Internal energy obviously increases because particles gain the energy due to the heat. So we're gonna write it increases. The temperature doesn't gonna change, it remains constant, does not change. The next part is B part. A student places a 300-gram piece of iron in the boiling water. Okay, mass is 300 gram. Until the iron at the temperature 100 degrees Celsius. Remove the iron from the water and place it immediately into 100 gram of water at 25 degrees Celsius. The iron cools and water warms until both reach the same temperature of 44 degrees Celsius. The specific heat capacity of the water is 4.2 joule per gram per Celsius. No energy is lost to the surrounding. Calculate the change in energy of the water as it warms up. So that's an easy question. Formula for this question is Q is equal to MC delta T. Q is equal to MC delta T or delta theta. We need to calculate Q, that is internal energy. Mass we already know that is 100 for the water, and the specific heat of capacity is 4.2. What is specific heat of capacity? It is the minimum amount of energy required to raise the temperature of a body of 1 kilogram to 1 degree Celsius. So what is change in temperature? That is equal to 44 minus 25. So we're gonna calculate it. The answer would be 8,000 joules. So we write over here 8,000 joules. Calculate the specific heat of iron. The next part is calculate the specific heat of iron. So we Note that the change in energy is 8000. We have mass of iron that is equal to 300. We need to calculate the specific heat of iron, that is C, and the change in temperature is from 100 degrees to 44. 100 minus 44. So we're gonna solve. You can cancel 20 from here, 20 from there. 80 divided by 56 into 3. So the answer is 0.48 joules. The answer of the question is 0.48 joules. So the question number 4 is completed. Question number 5 is water waves are transverse waves. We know that transfer wave doesn't need any medium to flow, and all electromagnetic waves are transverse waves. So part A required underline two other example of transverse wave. We know that seismic P waves are transverse waves, so we're gonna circle that, and X-rays are also transverse waves. Sound waves are longitudinal, and seismic S waves are also longitudinal waves. Figure 5.1 shows a wooden bar and a glass block in a ripple tank. The depth of the water in the tank is less than the height of the glass block, so that depth is actually less. This show the wavelength of the ripple tank. The wooden bar moves up and down once every 0.15 second to the crust. The speed of the water waves is 27, and this is time, this is velocity or speed. Calculate the frequency and wavelength of the wave. So the formula for the frequency is F is equal to 1 by T. It is 1 over 0.15. The answer is 6.7 hertz. So for the second part, we need to calculate the wavelength. The formula for the wavelength will be V is equal to F lambda, and we need to calculate lambda. Lambda is equal to V by F. What is V? V is given in the question, that is 27, and we have already calculated the frequency, that is 6.7. 20 divided by 6.7, we're gonna calculate the wavelength, and the answer is 4 centimeter. Okay, the wave diffracts at the right hand edge of the glass block. On figure 5.1, draw two crust. On figure 5.1, draw two crust after they pass the glass block to show the diffraction. So we need to draw the two crust. So let's say we need to measure this with the scale. If this is 1.2 centimeter, we need to draw over here 1.2 centimeter, keeping it straight, and same wavelength would be there over 1.2 centimeter. And due to diffraction, we need to show the bending, and this is how we're gonna show the bending. So we have plotted it. Now the next part is describe how a wave with a smaller length is made with the wooden bar. We can increase the frequency, so the wavelength would be reduced. So we're gonna write over here by increasing the frequency of the wooden bar. wooden bar. Okay. Describe how a decrease in wavelength affects the diffraction. There will be less bending when the wavelength is decreased. There will be less bending or less diffraction. So we're gonna write over here. There will be less bending or less diffraction. So question number 5 is completed as well. Now we move to the question number 6, that is from electricity. Figure 6.1 shows an electric circuit containing a filament lamp, a resistor R, and a 12-volt battery. Okay, and 5 meter. Okay, so this is over here. The reading on the ammeter is 0.25 ampere and reading on the voltmeter is 3. It is given in the question, 3 volt. We need to determine the readings on the other meter. As this is a series circuit, so the reading on the ammeter would be the same as shown in the 0.25 ampere and 0.25, because A2, they all are joined in the series circuit. In the series circuit, current doesn't splits up. And on what is the reading on the voltmeter, and we know that in for the voltmeter the potential difference is divided, so we need to calculate it. $12 is equal to V1 plus V2. We know we are given V1 over here, 3 plus V2. V2 would be 9 volt. So the answer is 9. Okay, calculate for this other part is calculate the resistance R. The resistance of resistor R. We need to calculate the resistor of resistor R. This is our resistor. So we know the Ohm's law. Ohm's law is that current is directly proportional to the potential difference provided that the physical condition like temperature remains constant. So V is equal to IR. So we need to calculate resistance from the formula R is equal to V by I. What is V over here? V2, that is 9, and current is 0.25. 9 divided by 0.25, the answer would be 36 ohm. Next question is asking about Ohm's law. I just stated that Ohm's law states that current is directly proportional to the voltage or potential difference. You can say potential difference, provided that temperature does not change. The next question is graph. Figure 6 point show the current voltage graph for the filament lamp. The battery in the figure 6.1 is replaced with a different battery which has a different EMF. The voltage across the lamp increases to 6 volt. Okay, voltage is increased by 6 volt. We're gonna draw the line, and at what point it touches the axis, we're gonna show that is equal to 0.31324, and approximately we can say it is 0.35. So we need to calculate the potential difference and we need to show our working. V is equal to IR. From the graph we have calculated 0.35, so I'm writing here over 0.35. From the graph we can see that the current is 0.35 and the resistance we just calculated, that is 36. The potential difference would be 12.6 volt. So the first we have the E is equal to 6 plus 12.6, both batteries. I'm gonna add the voltage, so the answer is 18.6 volt, or you can write 19 volt as of two significant figures. Both the answer will be corrected, but we are writing our answer in two significant figures only. So question number 6 is completed. Now the question number 7. Question number 7 is of the topic from the light. Ultraviolet radiation is one of the component of electromagnetic spectrum. State the two name of the components that have smaller wavelength than the ultraviolet radiation. We know that the longest wavelength electromagnetic spectrum have radio waves, then we have microwaves, then we have infrared rays, then we have visible region, then we have ultraviolet region, then we have X-rays and gamma rays. From this we can write down over here, X-rays have shorter wavelength compared to ultraviolet region, and gamma ray, X-ray and gamma rays both. Okay, so radio wave, micro, infrared, visible, ultraviolet, X-rays and gamma. This is the order. Okay, state one useful application of ultraviolet radiation. So sun, we can write sun tanning. Is used in ultraviolet radiation, or you can use it in the scans, in the banknotes. So many uses it has. Okay, exposure to ultraviolet radiation from the sun damages to eyes. State one type of damage to the eye caused by ultraviolet radiation. It can destroy the retina. It can destroy the retina. Now figure 7.1 shows a ray of light. The ray passes into a semicircular block of glass at A and leaves the glass at B, traveling along the surface to C. Okay, state the name given to the angle of incidence marked as 40 degree. So we know that when the refracted ray is making 90 degree, it is a critical angle. So we're gonna write over here is critical angle. Angle of incidence is critical when angle of reflection is 90 degrees. So the answer is calculate the refractive index of the glass. The formula for the refractive index is n is equal to 1 over sine c we have the value 1 over sine 40. This is our angle 1 over sine 40. The answer is 1.55. By writing in two significant figure, the answer is 1.6. Okay, so this was an easy question relating to total internal reflection. Question number 7 is completed. Question number 8. Question number 8 is of figure 8.1, shows a step down transformer used to operate an electric bell. Primary coil and secondary coil. State the material used for the core of the transformer. So soft iron is used because it can easily magnetize and demagnetize. So we use soft iron here. Okay. The next part is a current in the primary coil produces a magnetic field in the core. Explain how an alternating voltage is produced in the secondary coil. This is the principle of mutual induction. When the current changes in the one coil, it produces the magnetic field which induces the current in the other coil. That's how these magnetic field lines crosses with each other. So we're gonna write over here our answer. That is, actually the input current is alternating current. It changes the magnetic field in the primary coil. It also induces an alternating EMF in secondary coil as magnetic field lines occur. As magnetic field lines are crossed or cut. So the transformer, part C, the transformer has 46 turns on the primary coil, which is connected to a main supply of 30 volt to 30 volt. An output of 5 volt is used to operate the bell. Calculate the number of turns needed on the secondary coil. So we need to calculate the number of turns in the secondary coils. The formula is Vp, voltage in the primary coil, divided by voltage in the secondary. Number of turns in the primary coil divided by number of turns in the secondary coil. We have the value of Vp, that is 230 over 5, that is Vs, that is this is Vp. Okay, and P is 4600. We need to find Ns. So after rearranging, Ns is equal to 4600 multiplied by 5 divided by 230, 20. It would be 100 tons. So it would be 100 tons. So the number of turns are 100 for the secondary coil. State one change that can be made to the transformer shown in the figure 8.1 so that it can be used as a step-up transformer. We can see that this step-up transformer can only be made if we increase the number of turns of the coil of the secondary coil, or we decrease the number of turns of the primary coil. If the secondary coil have more number of turns, it is a step up transformer. So we're gonna write over here, by increasing the number of turns in the secondary coil compared to primary coil. Okay, first I need to adjust this angle. By increasing number of turns in the secondary coil compared to primary coil. So question number 8 is completed. The next question is question number 9, that is of radioactive source emits alpha particles, beta particles and gamma radiation. State which type of radiation produces the strongest ionizing effect. We know that alpha particle produces the strongest ionizing effect. So we're gonna write over here as alpha particles produces the strongest ionizing effect. And state which type of radiation is reflected most by magnetic field. Beta particles, because they are the lightest particle, that's why they are reflected more. If this question comes for the 2 marks, then you need to write the reason as well. The reason is they are of less mass. Okay, figure 9.1 shows a Geiger-Müller tube and counter. A radioactive source is placed 10 centimeter from the GM tube. In the figure 9.2, a piece of metal 5 millimeter thick is placed, and between the source and the GM tube, the readings on the counter have been corrected for background radiation. Show the count rate due to the source. Radioactive decay source 10 centimeter 800 counter, then 5 millimeter thick 200. First part require explain how the readings show that the source emits beta radiation and gamma radiation. We know that alpha radiation is only emitted, they have only power to move from 2 to 3 centimeter, but this is 10 centimeter the distance and the wall is 5 millimeter. It's very difficult for the alpha particle, but it's impossible that they would separate. So we would write over here beta particles are present because the count rate decreases. It cannot pass through the metal because they have low penetration power, and gamma radiation is present as it is passes through the metal, and we get a count rate. So we're gonna write over here beta particles are present because the count rate decreases and it cannot pass through metal. And gamma radiation is present as it passes through the metal because they have the high penetrating power. State why the readings cannot be used to show that the source emits alpha particles. I have already told that answer alpha particles are stored in by a few centimeter in the air, 2 to 3 centimeter. Alpha particles so by a few centimeter the air. The next part, describe one way that a radioactive sources move safely in a school laboratory. We can use handle at a distance, we can use place absorber, we can use lead box, or we can use thick metal box. So I'm gonna write only one because it contains only one. It is placed inside the lead box. It is placed in a lead box. So completed the question number 9. Now we move to the question number 10, that is last question, and this question belongs to the astronomy physics. That is the first time the question come in the syllabus. Astronomical distances are measured by the light year. State what is meant by a light year. This is simple. Distance traveled by light in 1 year is known as light year. So we're gonna write distance travel by by light in 1 year is known as 1 light year. The sun is one star in Milky Way galaxy. Okay. State the approximate diameter of the Milky Way galaxy. State a diameter of the Milky Way galaxy is equal to light year. So you're gonna write approximate answer, that is of 100,000 or 1 lakh light years. The next say there are several stages in the life cycle of a star. Complete figure 10.1 to show that the stages that a massive star go through after it has used up most of the hydrogen at the center of the star. Use words from the following list. So help is given by giving the words. First is nebula, neutron star, protostar, red giant, supernova, and white dwarf. Massive star much larger than our sun change into red supergiant. Then red supergiant becomes supernova, and supernova is changed to dash and dash. We're gonna write over nebula, and black hole or neutron star. State the stage in which the life cycle of a star where heavy elements are formed. So heavy elements are formed in supernova. We're gonna write over here supernova. So we move to the last part of our question paper, that is C part. The question is, current scientific understanding is that the universe begins 14 billion years ago, billion years ago in an event known as Big Bang. Explain one observation that supports the Big Bang theory. One observation is light from the distant galaxies are redshifted. So we're gonna write our assumption, our observation, that is light from distant galaxies from the different galaxies are redshifted. Okay. Explanation is at the beginning of the times the galaxies and stars were close. So cluster is was making they were becoming dense. The universe starts ex- expanding. So the radiation from far away star and galaxy have longer wavelength. So we're gonna write over here at the beginning of times the galaxies and stars were close, so they were dense. The universe start expanding. So radiation from far away stars and galaxies have longer wavelength. So this was our last question. Hopefully you will find great help in this paper. I tried to solve it by putting the formula and try to explain in an easy way so that you would get better understanding. If you like the video, do share and with your friends and subscribe my channel for more videos like this. Allah Hafiz.